Okay, this is 9.2D. Explain the failure of classical theory to justify the photoelectric effect. So classical theory prediction that they said the wave is dependent on the square of its amplitude, and they said that the is sufficiently intense the light is used. Okay, then the electron would absorb enough of energy to escape. But when the Planck come up and Einstein come up with a experiment of photoelectric effect, so they said that the quantum theory said that the photoelectron are emitted if a light frequency f is higher than the threshold frequency. Maksudnya nak cakap yang photoelectron ini adalah depends on frequency, okay, frequency of light, di mana frequency of light must be higher than the threshold frequency f0. And then classical theory prediction lagi dia kata required a free, dia maksudnya elektron ni perlukan masa lah, period of time before sufficient energy is absorbed for it to escape from the metal. Maksudnya untuk photoelektron tu keluar dia perlukan masa lama. Okay, sedangkan bila kita buat eksperimen, sedangkan waktu diorang buat eksperimen untuk quantum theory tu, untuk photoelectric effect, di mana dia kata photoelectron is emitted almost instantaneously. Maksudnya bila kita strike the surface of metal with EM radiation of light tu, so photoelectron tu akan immediate keluar, instantaneous keluar lah, bukannya pada period time yang lama lah, period of time. Okay, so classical theory juga prediction dia kata if the light of higher intensity is used, the kinetic energy of injected electrode can be increased. And then dia kata this is because the greater of intensity, the less energy of the light wave string the metal surface. So electron are ejected with the greater kinetic energy. Sebenarnya tak, bila kita buat quantum theory eksperimen di mana dia bagi tahulah, okay, dia kata kinetic energy increase with increasing of frequency of light. Maksudnya bukan bergantung kepada intensity. Intensity ni sebenarnya nak cakap independent pun pada pada kinetic energy. Maksudnya kinetic energy of the photoelectron is independent of the intensity of the incident light. Maksudnya dia tidak bergantung pada intensity lah. Walaupun intensity tinggi ke rendah ke, dia tiada efek pada kinetic energy. Okay, tiada efek pada kinetic energy. Jadi untuk kinetic energy ni tinggi atau rendah, dia bergantung kepada increasing energy of light, ataupun bergantung kepada frequency of light lah. Kalau frequency tinggi, energy akan tinggi. Lagi tinggi energy strike the surface of metal, so maka kinetic energy akan tinggi lah. Okay, so let's try this. We have light of wavelength of 350 nanometer falls on the potassium surface. The electron are emitted that have a maximum kinetic energy of 131 eV. Okay, so nampak tak unit dia berbeza-beza. Tapi kalau nak senang pada you boleh tukar dalam unit joule dulu. Okay, so dia minta cari work function. Okay, how to determine work function? Because they give you kinetic energy and then they give you the light of wavelength of light. Jadi kita boleh guna Einstein formula. E is equal to work function plus Kmax. Rearrange equation as a work function as a subject. So energy is equal to Hs C over lambda. Sebab dia bagi lambda light kan. Okay, Hs C over lambda and then minus with Kmax. Kmax you dalam electron volt, you kena tukar dalam joule. Jadi electron volt you darab dengan conversion unit dalam 1 eV kepada joule lah, 1.6 times 10 to the power of negative 19. So kita akan dapatlah work function dalam joule. Okay, so next dia minta cut off wavelength. Cut off wavelength sama maksud dengan threshold wavelength. Sama maksud dengan threshold wavelength. So threshold wavelength is equal to Hc over work function, di mana work function sama dengan Hc over lambda naught. Okay, so rearrange equation, kita akan dapat threshold frequency equal to H Planck constant times with C is speed of light and then divided by work function. Work function yang dah kira kat sini. Sebab tu saya guna dalam joule. Sebab bila kita kira wavelength, kira frekuensi ataupun dia sebagai energy, you mesti tukar dalam joule. It's easier for you to calculate. Then you akan dapat unit SI lah. 5.5 times 10 to the power of negative 7 meter. Then next, the frequency of corresponding the cut off wavelength. So dia nak frekuensi yang bergantung untuk cut off wavelength adalah threshold frequency. So threshold frequency is equal to C over lambda naught. So 3 times 10 to the power of 8 divided by lambda naught is 5.5 times 10 to the power of negative 7. We get the threshold frequency is equal to 5.41 times 10 to the power of 14 Hertz. Okay, next example, example 2, we have a molybdenum has work function of 4.2 electron volt. Okay, find the cut-off wavelength and threshold frequency for the photoelectric effect. So cut-off wavelength is lambda naught Hc over work function. As you can see that work function given here is in electron volt, you have to change in joule. So work function here in electron volt, so times with 1.6 times 10 to the power of negative 19 to get work function in terms of unit joule. Okay, then you akan dapat lah lambda naught is 2.96 times 10 to the power of negative 7 meter. How about threshold frequency? Threshold frequency is related with the cut-off wavelength, or we call it as the threshold wavelength. 3 times 10 to the power of 8 divided by 2.96 times 10 to the power of negative 7, we get the threshold frequency. The unit is hertz. Okay, next, calculate the stopping potential if the incident light has the wavelength of 180 nanometer. Okay, so light wavelength ini adalah energy of light. Jadi untuk dapatkan stopping potential, you kena tahu macam mana nak cari Kmax, sebab stopping potential duduk dekat Kmax. Okay, so saya buat Kmax. This is Kmax is equal to energy of light minus with work function. Okay, so energy is Hc over lambda light. So minus with work function, mesti tukar dalam unit joule. Okay, then you tolak, you akan dapat this one is yang atas ni adalah kinetic energy. Okay, di mana nilainya adalah EVS lah. EVS sama dengan 4.33 times 10 to the power of negative 19. So nak dapatkan stopping potential, you kena bahagi dengan E. Elementary charge adalah 1.6 kali 10 negative 19. You akan dapatlah stopping voltage is 2.71 volt. Okay, next, let's try this question 3. We have cesium has a work function of 1.8 electron volt. So light of wavelength is 720 nanometer, falls on the cathode of the photocell. Calculate the work function in unit joule. So work function tukar dalam unit joule, maksudnya 1.8 times with 1.6 times 10 to the power of negative 19. Dapatlah work function dalam joule. And then dia minta threshold wavelength. Threshold wavelength is equal to lambda naught is equal to Hc over work function, because kita ada work function kan. Work function mesti dalam joule. And then 2.8 times 10 to the power of negative 19, you get 6.9 times 10 to the power of negative 7 meter. Okay, next question C. Energy of light in electron volt. Okay, energy of light mesti berkait dengan wavelength of light lah. So energy equal to E equal to Hc over lambda. So lambda guna lambda light lah. Tak boleh guna suka-suka hati. Okay, so kita akan dapat dalam apa? Dia nak dalam EV kan? Okay, mula kira dalam joule dulu, dapat 2.761 times 10 to the power of negative 19. So bagi dengan 1 EV is 1.6 times 10 to the power of negative 19, dapat 1.73 electron volt. Okay, so next the question asks you to determine the maximum kinetic energy of the photoelectron. So guna Einstein formula, Kmax sama dengan E minus work function. Yang ni terpulang lah, nak kira dalam joule boleh, nak kira dalam electron volt boleh. Disebabkan energi saya dah memang ada dalam electron volt, 1.73. Saya tolaklah dengan work function dalam electron volt dalam soalan kan. So dapatlah negatif 0.07 electron volt. Kalau dapat negatif ni maksudnya tak berlaku emission of electron lah. Sebab Kmax dia negatif. Maksudnya photoelectron tu memang tak keluar. Okay, maksudnya energi supply 173 yang dia perlu serap 1.8. Memang tak cukup lah. Cerita dia.